Hello, welcome back to Cracking the Cryptic, and a fascinating looking puzzle today, which I think has a beautiful, elegant simplicity and also some intriguing features. We'll get to that in a moment. First of all, thank you to anybody who had a go at our linked Sudoku Patreon challenge that ended yesterday. Well done to everybody who sent in a correct answer. Hundreds and hundreds of those. Brilliant work. It's going to be a stiffer challenge next month. A Skunkworks collective set of puzzles brilliantly themed around duality, markings that have two meanings kind of things. Oh, it's absolutely epic. I love it. Now, that's coming up on Patreon. We have also put on Patreon the collaborative solve of me and Simon working through Dad Jokes Jabberwocky together, and that is brilliant. You may have seen it already. And of course, we've been working our way through the 500k puzzles on live streams. Those puzzles are available. Now, if you're not sure about our apps, there are a set of 7 older apps which you can pay for. They have either classic Sudoku, sandwich Sudoku, killer Sudoku with a certain amount of variety, but they are very much themed around those types of variant Sudoku, and you can click on the link for the apps under the video to find your way to those. Now, the more recent app is just called Cracking the Cryptic, and basically we're going to load up all new content onto that, and we've started with a set of 7 explanatory puzzles by Prasanna. They're free. Then there was Domino Sudoku, which will build up to 100 puzzles with crocky dots and XVs in them, which are not free. You pay for those, and that's many people have done so and spoken very highly of the puzzles. But when we reached 500,000 subscribers, we did also launch a pack of 23 free puzzles by a bunch of brilliant setters. Well, I mean, there's brilliant setters in all the apps, frankly, so don't worry about that. But those 500k puzzles are free, and now Simon and myself are working our way through them on live streams as well, and I think the next one is due to be on Thursday, which is tomorrow. Good. So that's tomorrow evening. Anyway, enough waffle about that. You can check out all the links under the video for that sort of stuff and our merchandise and Sven Sudoku pad. But this puzzle is from Yaroslav, who's in the Ukraine, one of multiple correspondents we have there, and we wish them well all the time, I can tell you. And we've featured Yaroslav on the channel a couple of times before. This one, he says, is pretty hard. Okay, thanks Yaroslav. And it's called Entangled. I don't know how to pronounce his pseudonym, Yar, I suppose, given the actual extension of the name. Now, the rules are these. Normal Sudoku rules apply. That's 1 to 9 in every row, column and box. Cages show their sums. There's just 4 little cages with 4 successive odd numbers in them, which is very neat. All very symmetrical. Digits cannot repeat along marked purple diagonals. This is where it gets quite interesting, because the 2 long diagonals are marked, but also this little 5-cell diagonal. I've never seen that as a non-repeating diagonal clue before. The blue line, this is a region sum line. It must have equal sums for each box the line passes through. So the sum of those 3 cells must be the same as the sum of those 2. And it's the same number all the way around. The sum of those 3 and the sum of those 2 and the sum of those 3 and those 2 and those 3 and those 2. And they're all the same going around this octagonal stop sign. But there's also this little region sum line, which works a bit like an arrow. That must be the sum of those 2. The total may be different for different lines. I would think it is. Not certain yet, but we'll see. Anyway, do give it a try on the first link under the video, but I am going to start now. Let's get cracking. Well, I mean, the only given thing I can see is that the 7 cage must be a 1, 2, 4. The 9 cage must be quite restricted, but there are 3 possible fills for that. I don't see what this is doing to the big region sum line. Crikey. I suppose there's going to be something in the fact that the total on the stop sign line is going to be something that can be in this group of 3 given the box and can be in 2 cells. The trouble is it could be the same too, even if it was, I don't know, 17. That could be 9, 8, 9, 8, 9, 8, 9, 8. So there's not much restriction from that. I can't see the role of the diagonal lines at the moment. Somebody doing bricklaying outside now, which is very annoying. Sorry. Oh, this isn't helping. What on earth? Okay, maybe. What is the minimum value of this 3 cells? Okay, with the 1, 2, 4 there, yes, it's gone up. The minimum value is 356, which adds up to 14. Now 13 is the biggest cage in the puzzle. If you put 14 in there, do you know the secret about the value of every box, and indeed every row and column in a Sudoku? They all consist of the digits 1 to 9. That always adds up to the same number. And I'm going to whisper that number to you now so you know it forever. It's 45. Right, so if this was 14 there, 14 here, this would have to add up to 18, which is 45 minus 14 minus 13. But 18's fine. That's not a conclusive number. Okay, this is obvious, and I've only just thought of it. 14 is the minimum for these 3 cells, being 3, 5, 6. But 17 is the maximum for a pair of 2 cells in a box. So the stop sign line has a region sum value of somewhere between 14 and 17. Okay, and if it was 14, plus 7 is 21. This would be the maximum, 987 here, 24. And then you could just have a 6 and a 5 here. If this was, yeah, that's getting quite interesting. It's the relationship between this group of cells and these 2 that I'm... Well, I mean, there's nothing to go on in this puzzle, so I'm thinking that must have some bearing. It's quite hard to see. These are going to have to be high to get these totals up to at least 14. In fact, we could actually, if I was a lunatic person called Pencil Mark, and I know that these cells always have to add up to at least 14 because of this group, I could pencil mark them like that. Which is not a problem, as I was saying, compared to the 1, 2, 4, but it might be, yeah, if this was 987, that would be 6, 5. So what happens if this goes up to 3, 5, 7? That's the next minimum thing, where it adds up to 15. So then these pairs would have to add up to 15. These would have become 986. And that wouldn't work, because you'd have to have at most 7 and 5 in these cells. And while the 7 can be in a 15 pair, 7, 8, the 5 can't be. How does that work? So what if this added up to 1 more, 16? But the trouble is there's going to be 2 ways of doing that. You're going to use the 3 every time. It's going to be 3, 5, 8, or 3, 6, 7. But these are always going to be 9, 7 pairs. Oh, and that's no good. That is no good because, yes, because if it was 16 on the region sum line, oh, this is amazing. If it was 16 on the region sum line, you wouldn't have a 9 in this group of cells. Because you can't do it with a 9 there. Therefore, in this box, sorry, you can't do it with a 9 there because the other pair would add up to 7 and they'd either need a 1, a 2 or a 4. That's weird, but it's true. So the 9 would be here. And that is a problem because if you add this up to 16, These are 9-7 pairs. That must be a 9-7 pair, and it would clash with a 9 here. And the same's got to be true with... No, the same doesn't have to be true with 17. 24. These would add up to 21. Oh, but these would add up to 17. Ah, that's the simple way to see it. Sorry, this has taken an awful long way around the houses to get to the logical conclusion. Right, if this is 14, that adds up to 24. I was going to say these can't, well, okay, no, it's not, there's not a generic conclusion. There is for the pairs like 9-7 and 9-8, which would have to be repeated here. Okay, so I'm going to explain it for a 16 total and a 17 total. If you had a 16 total here, you'd have to have 9 7s in these parts of the region sum lines. But this group would add up to 22 plus 16 here, which would be, because one of them was a 9 and one of them was a 7, that would make 38, which you can't do in 5 cells. And if this was 17, those would add up to 17, and these would be 21. And again, it's 38. I don't understand how it's the same total, but it is, and that's impossible. Now, so we're left with 14 and 15, and 15 doesn't work because in this box it would have to be 3, 5, 7 here. You'd get 9, 8, 6 here, 7 and 5 at a minimum there, and it doesn't work. Right, I'm sorry I've gone through that again and again, but frankly I wanted to prove it to myself. So it's 14. Blue, the region sum line on the stop sign is 14. And we get 7, 8, 9 there. Now these have to be a 5, 6 pair with an 8, 9 pair in these other cells. Let's get rid of the yellow. It's done its job. 14 is the number. Right, 14 here. Let's just put a kind of fake killer cage total in there. 27. This killer cage total is 18. Oh, it's not that helpful here. Maybe down here, 9 and 14. Let's do it again. 23, and that makes this total 22, which has 2 ways of being done, which both involve a 9. Ah, come on, get me something else, puzzle. 11 there, 14 here. I'm going to again do the fake killer cage marking. 25, but that leaves 20 here. So now I'm getting a bit puzzled again. What have I learned, if anything? I thought this was all going to be the same, but the 7 cage is helpful and the other ones aren't so much. Oh goodness. Okay, let's just look at row 2 in Sudoku. We've got 3, 5, 6 and 7 to put in, and 1, 2, 3 and 4 in row 3. 14, it's no use here. These add up to 20 though. Ah, there's definitely an, okay, hang on, there's definitely a 9 in these cells. So there's not a 9 in these two, but these, oh, I can take 7 out of all of these cells because we've got a 14 total and they can't be 7, 7. If there's not a 9 in those, there's not a 5 in these. Ah, this can't be 985 now as the 22 total, because these would both be 6s. Yes! That is 976. These don't have a 6. They're a 5-8 pair, so these are a 6-9 pair. This can't be 621, so it must have a 3 in it. There's some digit that must be in this group. It's an 8. I'm going to take out the 14 total now because I want to do proper pencil marking. I'm going to just try and, yeah, let's just remember that we've got 14s there. This is a 20 total. I've done that one and I'm going to get rid of that. Okay. So there's an 18 total here and a 20 total here. 8, don't know, right. So 11. Oh, that's a 5 X-wing. The only, yeah, that must be a 5-6 pair, and that must be a 5-8 pair. So that is going to use the 5s for both the rows and the columns. And therefore these cages don't have 5s in. Now I think there's still, you can still do this with a 2, 2, 3, 6 instead of a 1, or with 1, 2, it doesn't limit it much. And this one has lots of ways of filling it with or without a 5. Ah, hang on, these have an X-wing as well on 9s. Oh, hang on, yes, that's good. That's good, because remember this group of cells added up to 20. We've got 14 there on the region sum line, 11 there. Those add up to 20. And now they can't have a 9 in, because there must be a 9 in one of those two. Ah, yeah, so this is 875. That's the only way of making 20 in 3 cells without a 9. And they're looking at that. Here's our first digit in the grid. And I think we're going to get at least 3 others straight away. 9 down there, 6 down there. In fact, we have to make up these 14 totals all around the grid. 5, 6, 5. Now, this is, well, it can't be 1, 2, 8 or 2, 4, 5. But there are still 3 ways of making it up, I think. Ah, they're not done. Right, but there may be Sudoku to be done now. Look at the diagonals. Yes, 5 and 9 are sitting there and there. So they're not on this diagonal in any of those positions. So they have to be in these. You've got the same with 8 and 6 on the other side. So 8 and 6 are in those 3. I have a feeling that is not going to be any of those digits, but I don't know why yet. Another 1, 2, 3, 4 group in this column. This adds up to 14. Ah, 14, no. This adds up to 18, and it can't have a 9 or an 8 in it. Yeah, so it's 765. Yes, it is. That's good. And another 1, 2, 3, 4 group surrounding it. I suppose I could have just used symmetry. This, look, that's another 1, 2, 3, 4 group. They're all over the place. Ah, I've just remembered something about diagonals. Those cells all see each other, either through ordinary Sudoku, horizontal or vertical, or on the diagonal. So they have to be now a 1, 2, 3, 4 set of 4 digits, which means this can't be 1, 2, 3, or 4 in the middle. I bet it's going to be 7. You don't want to hear what I'm betting. You want to see some logical solving, I imagine. And I'm going to have to do a bit more. Right. Come on, we must have learned something about these pairs. There's an 8 in one of them and a 9 in the other. They can't both. This trio adds up to 14. This trio adds up to 13. So it's either 9 and a pair adding to 5 versus 8 and a pair adding to 5, or 9, 3, 1 and 8, 4, 2. Oh, I just don't know. I'm sure something has happened here, and I should be spotting it. Right. Look, 5 is looking at that cell, and this 5 is looking at those. There's only one place for 5 in row 2. There it is. That can't be 6 either. So 6 is definitely in one of those two. Five is in one of these two cells in box 7. Just trying to follow 5s around the grid now. Trouble is, I don't know if that's a 531 or if this is an 851. Oh, 9 can't be in the 11 cage. That's useful, yes. 9 must be in this 14 cage with 2 more low digits. So that group is going to be 9, 1, 2, 3, 4. And that means this is a 5, 7 pair. This is a 6, 8 pair, and we know the order. 6, 8. 5, 7, 8, 6. 9 is here in box 7. That is 1, 2, 3, or 4 on the diagonal. Now, what about 9? This is going to be 6 and 2 low digits, which is unsurprising. This isn't a 6. That's a 3, 7 pair. Right, there are a number of cells that they both see, and they include this cell, and this cell, which cannot be 3 or 7. Oh, I thought that one was going to be 7. This one is now going to have to be 5, 6, 8, or 9, just because we know there's a 1, 2, 3, 4 group there, and it can't be 3 or 7 now. This can't be a 3. 9, 8, 6, 5. 7 is in one of these two cells. This hasn't told me anything new about this 11 cage, which has a 6 in it. I've known that before. Nine. Did I not get anything more out of this? Oh, 8 on the diagonal there. So 8 can't be in these cells. It's in one of these two. No, it's not, because we've got an 8 in one of those. So we've placed 8 suddenly. Right, what about the other big digit? 6, yes, 6 goes there. 7 in one of those two, I don't know which, but 8 is now not in that group, so it's in this group with 2 digits that make 5. 9 is in this group with 2 digits that make 5, and 7 is up here in the column, which fixes the 3, 7 pair. This is so clever, intricate. You can see why it's called entangled, actually. That has to be a 9. This is from 1, 2, 3, 4. In fact, given that that's 6 and a pair that adds up to 5, that pair adds up to 5 as well, and that's not a 2. It's also not a 3, because we've got a 3 in this row on the region sum line. So 3 is now in one of those two. Oh yes, we've got a 3 in this box. Actually, let's use the diagonals again. 7 there, looking straight down there. 3 there, looking at this. Now we've got a 1, 2, 4 triple on the diagonal. 7, 3, 5. This is a 6, 8, 9 set, and 9 is also on this diagonal. So it's 9 in the center. That's a 6, 8 pair. 8, 7, 9, 6. This includes a 5 and a low digit, weirdly. Ooh, it doesn't feel right with the symmetry. Right, 3 is not in this group, so it's in this group, which is 9, 3, 2. This is 8, 4, 1. This is a 2, 7 pair down here. I can do that. 7 below the 2. That's not a 2. Now, there's only going to be one way. This can't have a 2 in it, so it's not 3, 2, 4. It's 3, 1, 5. That becomes a 4. That's going to give us... No. This is 2, 3, 6. That makes 11. This is 1, 4, 9. Oh, loads of pencil mark clearing up to do. That's the sort of admin I enjoy. This is 2, 4, 8 along here, so these can't have a 2 or a 4 in. Now there's the diagonals, they can't have a 4. These can't have a 2. In fact, remember this 1, 2, 3, 4 set. Yeah, that's really helpful now. That's the 1, 2 pair. So this, yeah, the simple way to look at it is if that's a 1, 2 pair, that can't be 1 or 2, nor can this. Now we've got a 3, 4 pair on the diagonal, leaving a 1, 5 pair in the remaining cells. 2, 3, 4, 7. That's everything pencil marked in the grid. Now, I should start thinking about this or this weird diagonal. No, let's do more pencil mark tidying up, because I think we should. It might actually throw something ordinary out by Sudoku. Now, all of these cells have been restricted to 2 possibilities, which carries enough symmetry that I imagine we can't do any more than that at the moment. 9s, we've got various cells with a possible 9 in that can't have this central 9. All of those can't be a 9. And that's it. I think now we're going to have to move on to these 2 weird clues. Let's try this one. So, if that's a 5, then this is 2 or 3 to make 7 or 8. If it's a 1, this is 4 or 7 to make 5 or 8. So I can't eliminate any of the possibilities. Oh, I can. I can. This is lovely. Look, that's a 1-5 pair. Now they both see this cell. That one sees it very obviously by a horizontal Sudoku move. This one sees it because it adds to that cell to give this, so it can't be identical. So given that there is a 5 in one of those 2 cells, there can't be a 5 there. That's now 7 or 8. This can still be a 1. This can't be a 4 anymore. Is that it? I don't know. Have we suddenly got a quadruple or something out of that? It doesn't look like it, but I don't quite know where I should be looking. This 7, 8 maybe. 5s. I don't know. 5's in one of those cells. No, this is weird. Yeah, sorry, I can't see what to do next. There's probably some other move like, I mean, I was quite pleased with that. Is it this line? There's not that many digits possible along it, but no, I'm going back to consider this again. What's going on here? Oh, if that was 5, this would be 5. Oh, that's really interesting. If this is 5, this works. My goodness, there are probably other ways of doing this, but if that's a 5, the 5 in these 3 cells is then here. However, if it's a 1, then this has to be 7 and this has to be 8, and they're both seeing this cell, which again has to be 5. So this is a 5 by virtue of either way that either of a dichotomy of ways that this trichotomy works. I don't know what I'm talking about now, but anyway, that's a 5. These aren't. I mean, that probably doesn't get me all that far again. Yes, it does. Yes, it does. There's a 2, 3, 6, 7 quadruple. Beautiful. So that's a 4. That's a 1. That's an 8. That's a start. 1 out of those, 4 out of these. Oh, what next? Is it? There would put 8 here. What about this then? If that was a 2, it wouldn't have much impact on the line. If it was a 3, This would be a 4. Oh, look at that. That is immense. This is fantastic. And you really can see why it's an entangled spider's web now. Look, if this was a 3, this becomes 4. And remember, along this line, that's because along this line you can't have repeats. That becomes 1 and that becomes 5 then. But what happens to this? It's seeing that 1 and 5. That is so elegant. If this is a 3, 4, 1, 5, impossible. So, wow, that's not a 3, that's a 2. And okay, that takes a 2 out of this cell. What else does it do? It takes a 2 out of this cell. Now, can we do the same again? To avoid having a 1, 5 there and making that impossible, I was going to say, do we have to have a 4 on this line to avoid having a 1, 5 pair? Yes. I think we do. Is that right? I'm not sure I can work this out fully. This mustn't be a 1, 5 pair. But if you didn't have a 4 in these 3 cells, what I'm saying is if that's a 4, oh, it happens again. That's basically what happens, just as it happened up here. If that's a 4, you get 3, 1, 5, impossible. So that's not a 4. So it's exactly analogous to that cell. That's so bizarre. 8 there gives us apparently a 7 up here, and that is going to be helpful. Those can't have a 7. The 7 in the central box is here. Now this small equal sum line is done. And now I think we're going to suddenly just finish off, is what I'm guessing at this point. As complicated as this puzzle has been, as fascinating as it's been, I think we might be getting there. Look, this central row is fully done now. 3, 2, 6. The 2 fixes 2 and 3. I think we're going to finish off rows 5 and 6 entirely. We must be doing that. What a brilliancy this is. We've never attacked these cells at all. But I'm hoping that they come last. That can't be 2. This can't be 3. We've got 1, 4, 5. Oh, that's become a 6. That makes this a 5. That makes this a 1. And this a 4. Isn't that brilliant? So no 1s there. No 6s here. No 4s here. No 5s here. 8 is resolving those. That does 9 and 7. I feel like I must be able to just bounce up and down. Yes, 1 is looking at those 2. That fixes 2 and 4. 5 and 3. 6 and 3. Now it's just these tinies to do. And look, that one is done. This is it. That's how to disambiguate this whole thing, is because that 3 is on this purple line. So that becomes a 4. Oh, that is an absolutely epic puzzle. That feels more like a discovery than a construction. It is so elegant. It is so neat. And that has been enormous fun. Wow. I mean, if you seared through that, I'd love to know how. I'm quite pleased with that path through it. Every clue contributed in a beautiful way. Excellent puzzle. Thank you so much, Yaroslav, and good luck to you. We shall be back with more Sudoku tomorrow, but as it is, bye for now. Thanks for watching.